Okay, so today our focus is angles and angle measures. So every angle is going to be drawn in standard position, which is when the vertex is on the origin and then one ray is on the positive x-axis. We call the initial side the ray that's on the x-axis, and the terminal side the ray that is not on the x-axis. So when we draw these, you're going to want either a highlighter or a marker just so that it shows up on the axis for our rotations. And then you are going to have some very specific notations here that I'm going to go over with you. Okay, so the first type that we're going to draw is a positive rotation. Okay, so the initial side is going to start on the positive x-axis. So that's going to be here, and then we're going to draw an arrow with that. Okay, that is our initial side. Okay, that's where it starts. Okay, and then the terminal side can be anywhere. Okay, I'm going to just put this in quadrant 2 for our original. This is called the terminal side. Okay, so your angle is always going to start what I have highlighted in blue there, and then it is going to end where I have highlighted in green, but that space is going to change. When you are making this angle, you are going to draw in an angle that shows where it starts to where it ends up. So you do need the arrow on this to show it starts with the initial, it goes to the terminal, and then whatever your degree is, you're going to write theta equals that degree. So when we're thinking of degrees, you might remember that we're going to start at 0 degrees. Okay, and then straight up the y-axis is 90 degrees. And then this part here would be 180. So each quadrant is 90 degrees. So you add 90, you add 90. If you add 90 to 180, what do you get? Yep. And then if you add 90, you go to 360, and then that's back at the start. We are going to be referencing the quadrants, so don't remember those. You're going to want to write them down. Your quadrants always start where both x and y are positive, and we use Roman numerals. Okay, so x and y are both positive in quadrant 1. Okay, and then from there you're going to go counterclockwise. So you have quadrant 2, quadrant 3, and then quadrant 4. Okay, have you guys ever done a negative rotation before of angles? Alright, so when you do a negative rotation, you are still going to start here at the initial side, and you can still end at the terminal side. So we're going to use the same initial side and the same terminal side. Okay, so we start here, end in there. Okay, and then this is your initial side. This is your terminal side. You will not have to write this for every single one. Okay, we're just writing these out for these two because we're defining them. Now, if it's a negative rotation, instead of going counterclockwise, which is what we did here, we are going to go clockwise. So you start at the initial side and you end up at the terminal side. Your theta is still going to be a degree, but in this case it would be a negative degree. So you still start at 0, but then you would have negative 90 below. This would be negative 180, negative 270, and then negative 360. Okay, so we have a positive angle and we have a negative angle. Okay, these are angles of rotation. So when we are drawing these angles, we're going to rotate the terminal side, and we are going to keep the initial side in place. Okay, if you rotate counterclockwise, that is going to be a positive angle. And if you rotate clockwise, that's going to be a negative angle. Okay, so counterclockwise is going to produce a positive angle. And clockwise is going to produce a negative angle. Now we labeled these 0 through 360 and 0 through negative 360, but angles can be rotated more than 360 degrees. Okay, angles can be rotated more than 360 degrees. So I'm going to show you just a quick sketch of what that would look like. Use a lighter color so you can see it better. Okay, so if you have your X and your Y axis, alright, let's say we're starting here. We'll still end up here. Okay, so watch me do this and then I'll give you time to do it yourself. If you had to rotate more than 360 degrees, you would start here and you would do a full loop around and then you would end here. Okay, so when you do this, you're going to do a full loop around, then you're going to end at your terminal side. Okay, so if you're just looking at this part, it kind of looks like a snail shell. Okay, and then that would also work in the negative direction. All right, so you can draw your example. And then, for example 1, we're going to draw the angles in standard position. There's going to be a couple things I'm going to have you look out for. And then I am going to have you use a straight edge today. That is also a protractor. Some are protractors, some are safety. 3, 4, 5. I just want you to have the option of the angle. If you guys have your own protractor, you're welcome to use that. Okay, so if you have a protractor, if you have a protractor, then if you want to draw the angle precisely, you can. Okay, we're going to estimate, but we're going to estimate pretty accurately. All right, so I'll kind of talk about what I'm looking for there. So when we are drawing the angle, the first thing we're going to do is draw the initial side. Okay, when you're doing this on your own, you aren't already going to have those in there. You'll draw your X and your Y, but when you're drawing this, I do recommend that you use a marker or a highlighter so that we can see that. And I'll tell you the same thing on your assessment. So if it's 320, keep in mind that this is 360, this is 270. All right, so if I'm 320, when you guys are thinking about this, are you thinking of it being 40 degrees from this line? That's what I would think of. Okay, so you could draw in a 40-degree angle. Again, it does not have to be exact, but some people wanted to draw exact in the other one. So if you wanted to draw a 40-degree angle, you just line these up here. Okay, and then you would line this up at the center, and then you would draw your 40-degree angle. Okay, another way that you can do this is you can just remind yourself that if you have an angle, if you have a quadrant, okay, the angle measure of a quadrant is 90. So what is half of the quadrant? 45. So it has to be a little less than 45 degrees. Again, I'm not going to be pulling on a protractor, but you do have to show that you understand that it's like a little bit less than halfway. And then what you're going to have to show is theta equals 320. Okay, so everything I have in green on this value, you also have to have. So you have to have an initial side with the arrow. You have to have the terminal side with the arrow. You have to have this little pattern here with the arrow. Right? Okay, so it starts here, then goes around, and then you have to have the theta equals 320. You don't have to have these angle measures in when you're doing it yourself. Okay, you don't have to put in that this is 40, but you are welcome to do that. Okay, it's just the stuff in green that I have to see. Okay, and then when you're ready, you can move to part B, which is a negative 110. So if it's negative, we're going to be going in the opposite direction. Again, we always start here at 0. So your first step is always going to be the same. You're always going to have this initial side on the positive x-axis. You're going to have your arrow. Okay, it's going to consist of those two rays. And then if it's a negative, this is negative 90. So in my mind, I would be thinking, all right, from 110 to 90, what's the difference in degrees? From 110 to 90. 20 degrees, right? So I just have to do this 20 degrees past. Again, I'm not expecting you to pull out a protractor and do that. I'm just expecting you to give a good estimate. So if you want to use your straight edge, just to make a straight value there. And then we're going to draw our arrow, and then theta is negative 110 degrees. Make sure you put the degree symbol. Sorry, and for first hour, I did talk about that. Sorry. Okay, so the symbol that we're using for the angle is theta. Okay, so theta is going to become very common to you after this unit. So theta is what we use to show the angle. Theta is a Greek letter. When you have theta in a document, it's usually italicized, and there's like a little loop to it, which is why when I make it, you'll see I'll do like a loop like that. So it's like a 0 with a line through it. You can also just make it as a 0 with the line through it like that. Okay, so either way you make these. I need to get a tennis racket so you guys can. Okay, so when you're making your theta, just do your best. Again, either a 0 with a line, or if you want to do, I call it my fancy theta, you can do that as well. Okay. All right, so for C, 990. So we're going to do one that's more than 360. You know that one time around is 360. What would be twice around? Yep. And then if we're going to 990, if I added another 360, would that be less than 990 or greater than? Greater than. So let's just start at 720 and then keep adding 90. Because what's 720 plus 90? Okay, so that would be here, and then plus 90, 900, and then plus 90, 990. All right, so then what I'm going to do is I'm going to put in my initial side and my terminal side, and then I'm going to do my rotations. Okay, and again, if you want to watch me first and then I'll give you time to do your own, you can. So when I'm doing my rotation, I always start here. If it's positive, I have to go counterclockwise. So one time around is 360. Twice around is 720. And then I go to the 990. Okay, so you can try that now. So one time is 360. Loop again for the 720. And then keep moving. Try to do it as circular as you can. Again, I'm not expecting perfect. And then you're going to have your theta value is equal to 990. And I want you to feel good about what you got there. You can flip it over. All right, so the next thing we're going to talk about are coterminal angles. Okay, so coterminal means that you have angles in standard position that have the same terminal side, right? If you think of co-workers, right? Those are workers who work at the same place. Coterminal are going to be angles that have the same terminal side. And it is called the terminal side because that's where it ends or terminates. Okay, so coterminal angles are angles in standard position with the same terminal side, and there is an infinite amount of these angles. So there's an infinite amount of coterminal angles. Okay, and that's because of the rotations. You can rotate an angle an infinite number of times. Okay, so you can rotate an angle an infinite number of times. Use the number symbol. Okay, and then one other symbol that I'm going to be using besides theta is when it says angle. In geometry, you probably have like this symbol for angle. So I do this with the line through it. Okay, so you'll see that. You just want to do the angle without the line through it, that is fine. Okay, so to find coterminal angles, you are going to add or subtract 360 from the given angle. Okay, and we're going to talk about why that is using this model. So whenever you're trying to come up with an angle, okay, we're going to put this angle in quadrant 1, switch it up a little. Okay, so this is going to be your theta value. Remember, this is the initial side, this is the terminal side. If they have the same terminal side, you can draw the same angle, well, not the exact same. You can draw another angle with the same terminal side just by going the other direction. So this would be a new angle that I have there in blue. Okay, so what I have in blue is coterminal to theta. Now, if you look at those two angles together, you see how they make a circle? Don't want to circle this one, but it is going to be a full rotation of 360, okay? And that is why you can add 360 from the given angle, okay, to find the other one. So this is in quadrant 1, right? Let's say this was 45 degrees. To find this angle, you would just have to do 360 minus 45. Okay, so that's how you can find the coterminal angles. You can also add or subtract the multiples of 360, which you can multiply them to get there faster, but I'm going to show you some different strategies as well. So we already talked about 360 times 2 is 720 because that was twice around. So if you wanted, you could also add or subtract 720 degrees. Okay, you could add or subtract 360 times 3, which is 1080. You could add or subtract that right off the bat. That would be fine. And you would do that only if you notice some bigger numbers. Okay, so to find coterminal angles, what you have to remember is that you add or subtract 360. Okay, so to find coterminal angles, you're going to add or subtract 360. Okay, so for example 2, we're going to find the measures of both a positive angle and a negative angle that are coterminal with a given angle. So that means that you have to find a positive and a negative. Okay, so we're finding 2 coterminal angles. Okay, for the first one, we're going to draw a picture, and that's just so you can understand what we're finding. And then from there on, we're just going to use the addition and subtraction. Okay, so 65 degrees, I know that that is more than halfway. About 25 degrees there. Okay, so to find that negative coterminal angle, all you are finding is this angle here, because together they make 360. Okay, so all we have to do is do 65 minus 360. We are doing these without a calculator. I believe these are on your no calculator section of your quiz, which is why I'm having you practice that. So if you're subtracting, it's a lot easier to just do the 360 minus the 65 and then put your negative on it. Okay, I think of it like this. If you do 360 minus 60, what do you get? 300, and then do 300 minus 5. Yep, so it's negative 295 degrees. Okay, so now we found a negative angle. Okay, when you are finding the positive angle, what you are finding is the rotation. So if this is 65 degrees, the other angle that you're finding is one that loops around and then goes to the same terminal side. So that's why we do 65 plus 360. Okay, and that's going to give us 425 degrees. So now we have one positive and one negative. Okay, again, for this, you do not have to draw the picture for each one. I just want you to understand what coterminal angles are. Okay, so we need a positive and we need a negative. Because there's an infinite amount of rotations, there's really an infinite amount of answers for this. So one thing that you can do is you can add 360 to this right away. So 0, 7, 7. You can use that as your positive angle. Okay, so this would be your positive. And then if you subtract 360, what's the difference between 410 and 360? 50. So this would be another one that could be positive. Okay, that's not your negative one. If you want to find a negative one, you have to subtract 360 again. So if you have negative 360 and you add 50, what do you get? That's okay. 310, negative 310. So this would be your negative angle. Okay, do you have to find all three of those? No. Might you do it anyway? Yeah, because if you add this first, right, then you might find that. And then this is where, do you notice it's more than 360? So if you wanted to subtract 720 right away, you could. Okay, if you wanted to do the multiples. All right, try this one. Theta equals negative 360. So I want you to find one positive and one negative. All right, so if you subtracted 360, what do we get? Yep, so that should be your negative angle. Okay, now if you added 360, what did you get? 0. So is 0 positive? Nope, it's not positive and it's not negative. Okay, so 0 is neither, so you're going to add 360 again. Okay, and then this is going to be your positive angle. Now, could you add it again? Could 720 be an answer? Yes. Okay, but generally people find the first positive and the first negative, and that's fine. Okay, any questions for me on coterminal angles? Okay, so they have the same terminal side. The last thing we're going to talk about are reference angles, and we're going to be using reference angles a lot. Okay, so a reference angle is the positive acute, angle that is formed by the terminal side of theta, okay, which is your angle, and the x-axis. Okay, so it's the positive acute angle that is formed by the terminal side of theta and the x-axis. Now, when you are finding this angle, it is always going to go to the side of the x-axis that it is closest to. So it always is going to go to the shortest distance. Sometimes it's the positive x-axis. Sometimes it's the negative x-axis. It's whichever side is closer. Okay, so we are going to find the shortest distance. It always will be positive, okay? And acute means it's between 0 and 90. There are cases where the reference angle can be 90. Okay, so in some cases the reference angle equals 90, but it will never be more than that. Okay, and we'll talk about a case where it is 90. All right, so we're going to do an example. Let's say that your theta value is equal to 135 degrees. Okay, if theta is 135 degrees, you are going to start on the initial side, like always. And then you should start thinking about, okay, if this is 90 degrees, where's my 135? That's 45 degrees from here. So I'm going to put this right in the middle. And then I know I gave some of you this one. If you have this one and you wanted to do it, I don't know if you guys remember how to use these. You would put like your 45 here, right? And then you would do like that, and then you would put this here. Again, an estimation is fine. All right, and then your theta value is 135. To find the reference angle, it is going to be the distance from the terminal side to your x-axis. So you really have two different pathways, right? You can go from here to here, this part, or you could go from here to here, which is what we have in purple. Which distance is shorter? The one that I have marked in pink, right? Okay, so your reference angle is going to be the 45 degrees. Okay, because the distance from the terminal side to this part of the x-axis is 135. And then how did I know this is 45? Yeah, 180 minus 135. Okay, because you know the straight line is 1. Okay, for example 3, you are going to find the measure of the reference angle for each given angle. Okay, when you do this in your homework, you're going to be doing that with what we did on the front. Okay, so we are going to be drawing the angle for each of these. Okay, so for each of these, we're going to draw the angle and we're going to find the reference angle. And again, that's what your practice is going to be today. All right, so for A, we have theta equals 325 degrees. So the first thing you're going to do is just draw that angle. So I want you to think about that. No. Okay, so if it's 325, when I say think about how you're doing that angle, you're thinking about where you are putting that line in relation to 360 or 270. Okay, so we're all starting that here. And when I say I want you to think about where you're putting that line, is what I'm saying is, okay, if I'm trying to get to 325, I know this is 360 and this is 270. I want you to think about what the degree difference is. So what's the distance in degrees between 325 and 360? 35 degrees. So when I'm making that side, I'm thinking of, okay, if that's 35 degrees, here's 45, so maybe I just make that a little bit less here to 35. Again, I'm not going to pull out a protractor, but I do need to see that it's a little bit less than that. So when you're making this angle, because you've already thought about how this is the distance of 35 degrees, you've already done that work for finding your reference angle. I'm going to use my angle symbol. Okay, so when you're thinking about that in terms of how you are making your angle, you are likely going to be thinking about what the reference angle is. Okay, your reference angle should always be positive and it should always be acute, unless there's a special case where it's 90 degrees. Okay, so your theta value is negative 105 for part B. Okay, so I just want you to start by graphing that angle on there. So remember, your reference angle always goes to which axis? The reference angle always goes to which axis? The X or the Y? The X. Okay, so don't accidentally tell me what the reference angle is to the Y, because that won't be a reference angle. Okay, so for negative 105, again, we're just starting here. And because it's negative, we're going clockwise. So we have negative 90. So I would be thinking, okay, from 90 to 105 is how many degrees? 15. So I'm just going to put this a little bit past it. Okay, and so this is my negative 105. Okay, because this angle here is 15 degrees, that's not my reference angle because I have to go to the x-axis, but I can use that to help me find my reference angle. If this is 15, what does the reference angle have to be? 75, because together those two should make what? 90. Yeah, so it's all about these quadrants here. Okay, remember it's going to be 90. Sometimes people forget and do 100 because we're used to doing that whole value there. So that will be 75. All right, and then go ahead and try the last one when you're ready. Theta equals 50 degrees. What do you get for your reference angle? The same thing is right. So in quadrant one, okay, in quadrant one, this is special because you are always going to get the same angle because it's the shortest distance. So I would say, all right, that's halfway, so I'm going to adjust a little bit. Okay, and this is your theta equals 50 degrees. So when you are doing the shortest distance to the x-axis, it can't be this. It will go past that axis. If you're going past an axis, then it's not the shortest distance. The shortest distance is just the way that you came. Okay, so your reference angle is going to be 50 degrees. And this will always happen in quadrant one. Okay, so in quadrant one, your angle, your theta should equal the reference angle. Okay, so in Q1, theta equals your reference angle. That's a special pattern. Can you guys think of a value for theta where the reference angle would be 90? Yep, if the terminal side was there, so that could be if theta equals 90. Could be if 90, yeah, 90 plus the 360. Yep, if it was 270, great. Okay. What if it was 180? If it's 180, your reference angle would be 0 because you wouldn't have any distance to get to that. All right, so for your assignment, which I'll put the book on the board so you guys can get started on it. You're doing 1 through 13, which your book only says to draw the angle. You are also going to find the reference angle. So you're going to do example 1 and example 3 together. Okay, so 1 through 13, you'll be drawing the angle and you'll be doing the reference angle. Okay, and then 17 through 21 should be your coterminal angles there.